Orientation of birds. A. For many of us, the way birds are able to orientate is both astounding and difficult to appreciate fully. For instance, the annual migration of the golden plover of the Pacific takes it from Alaska to Hawaii on a flight of well over 3,000 kilometers. And if it were to deviate by only 1 degree, it would miss the island on which it nests. B. The first systematic studies on orientation in birds were made possible by the homing instinct exhibited by so many species. Birds are caught at a time when they show an attachment to their territory, especially during the nesting season. They are taken to some spot, released, and the percentage of returns is recorded. The distance can be varied, and the direction, as well as the method of transporting them. And then the influence of climatic and other factors on their ability to find their way home can be studied. These experiments have shown a wide variation in ability to home, and 3 types of homing behavior have been identified. C. In the first type, birds methodically explore the area in which they are released until they pick up some familiar feature, and then they quickly find their way back to the nest. Such birds possess a highly developed visual memory, as experiments with pigeons have shown. Domestic pigeons have been trained to peck at a certain point on an aerial photograph with a system of rewards, and 4 years later, the birds were still able to respond to this training when placed on the aerial photograph. Birds' eyes have a power of resolution 2 to 3 times greater than ours, enabling them to pick up very fine details. If a bird uses only this type of homing behavior, however, it can only succeed if the point of release is not too far away. If the birds are transported 800 kilometers from their nest, it is only by good fortune that they find their way back as a result of long exploratory flights. Usually, the area known to a bird is its feeding territory. Released within this area, the birds soon make their return. Release them outside it, and far fewer return. However, if a bird is released for a second time in the same place, its visual memory comes into play, and the bird, no longer requiring tedious exploratory flights, will return much more quickly. D. The second type of homing behavior is shown by birds that are capable of choosing their flight direction and holding to it for the rest of their journey. How do they decide what direction to take? They appear to choose their normal migration direction, even if they are released in a different place from their usual starting point. If, for example, birds which normally fly to the northeast to reach latitude 45 degrees north are released at that latitude, they will immediately start flying northeast anyway. So, if they're released further to the west, they maintain the correct direction but fly west of their destination, and so fail to arrive. E. The third type of homing behavior shows the highest degree of orientation. Released at one point, the birds immediately take stock of it, compare its position with that of the nest, decide on the direction, and fly off. This happens even if the birds are in a country right off their migration routes where they have never been before. In one example, a Laysan albatross returned to its nesting area on Midway Island in the middle of the Pacific, having flown over 5,000 kilometers from the west coast of the USA in just over 10 days. This is a perfect example of the third type of homing, for the albatross clearly couldn't rely on any landmarks over the vast expanse of the Pacific Ocean. F. The percentage of successful birds varies greatly, being highest in those species with a strong migratory behavior. Thus, the lesser black-backed gull is more migratory than the herring gull and more often reaches home. Great migrants, such as the swift, have the highest percentage of returns. In one case, 7 out of 9 alpine swifts were recaptured at their nests after being displaced some 1,400 kilometers. One made the journey in 3 days. G. What part does heredity play in all this? 2 research studies suggest that instinctive, that is, genetically inherited behavior patterns play a part in navigation. The first was carried out by Ernst Schues, and it is highly significant. Schues caught first-year European storks and released them later after the departure of the adult storks at a time when they normally make their southwest autumn migration to Africa. The recaptures showed that in spite of the fact that there were no adults to guide them, the birds unanimously headed southwest. This was almost striking finding, for it showed that the birds had an innate and unlearned attraction for the African wintering area that they have occupied for thousands of years. H. The case of starlings is a little different. These birds have a great aptitude for homing, but this behavior differs in the different age groups. Birds that were shifted to the southeast of their normal migration route split into two lots. The adults, in full possession of their gift for orientation, found their wintering area by modifying their direction by 90 degrees, whereas the juveniles sought their winter quarters to the southeast of their real position.